Flash floods are among the most destructive and sudden natural disasters, characterized by a rapid surge of water into low-lying areas. Typically caused by intense rainfall over a short period, flash floods occur with little to no warning, making them particularly dangerous. These floods can occur anywhere, from urban centers to rural landscapes, and can cause significant damage to infrastructure, homes, and lives. This audio story explores the causes of flash floods, their environmental and societal impacts, and strategies for mitigating their effects. By understanding how flash floods form and the conditions that exacerbate them, communities can better prepare and protect themselves against this natural hazard. What is a flash flood? A flash flood is a rapid flooding of low-lying areas, usually within 6 hours of intense rainfall. However, they can also be caused by dam breaks, landslides, or the sudden release of water from glaciers or snowmelt. Unlike regular floods, flash floods occur with little warning, making them particularly perilous to people, animals, and infrastructure. Flash floods can turn streets into rivers, sweep away vehicles, and inundate buildings in a matter of minutes. They are typically short-lived but devastating, and their sudden onset makes early detection and evacuation challenging. Distinguishing flash floods from regular floods. The main difference between flash floods and regular floods lies in their timing and onset. Regular floods develop slowly over days or even weeks, allowing for advance warning and preparation. Flash floods, on the other hand, develop rapidly, often catching people off guard. Regular floods are typically the result of prolonged rainfall, while flash floods arise from intense rainfall over a brief period. Causes of flash floods. Intense rainfall. The most common cause of flash floods is heavy rainfall in a short period, overwhelming the capacity of the ground to absorb water. When rain falls faster than the soil can absorb it, the excess water flows overland, following the path of least resistance. In areas with steep slopes or poor drainage, this can lead to sudden and severe flooding. Thunderstorms, tropical storms, or hurricanes can produce intense rainfall that triggers flash floods. Topography. Topography, or the shape of the land, plays a critical role in flash flood development. Flash floods are more likely to occur in areas with steep terrain, such as mountainous regions, where rainwater rushes downhill quickly. Valleys and low-lying areas, particularly those near rivers or streams, are also prone to flash flooding because water naturally flows toward these areas. Urbanization. Urban areas are especially susceptible to flash floods due to the abundance of impervious surfaces like asphalt, concrete, and buildings, which prevent water from soaking into the ground. Instead, rainwater quickly accumulates on streets and in drainage systems, often overwhelming sewers and causing flash floods. Poor urban planning, inadequate drainage systems, and insufficient flood management infrastructure exacerbate the problem. Snowmelt and ice dams. In some regions, flash floods can occur during periods of rapid snowmelt. As temperatures rise, snow and ice melt quickly, overwhelming rivers and streams. Ice jams can form on rivers, blocking the natural flow of water and causing upstream flooding. When the ice eventually breaks, it releases a sudden surge of water downstream, causing flash floods. Dam or levee failure. Flash floods can also be triggered by the failure of man-made structures such as dams or levees. A dam failure can unleash an enormous volume of water in a short period, devastating downstream communities. Levees, which are designed to control water flow, can break or be overtopped during extreme weather events, resulting in catastrophic flooding. Saturated soil and ground conditions. If the ground is already saturated from previous rain, snowmelt, or irrigation, any additional rainfall can quickly lead to flash flooding. Saturated soil cannot absorb more water, so even moderate rainfall can produce significant runoff. This is particularly true in agricultural areas or regions that have experienced prolonged periods of wet weather. The impact of flash floods. Human loss and injury. Flash floods are one of the leading causes of weather-related fatalities worldwide. Because they strike suddenly, people are often caught unprepared. Fast-moving water can sweep away vehicles and pedestrians, leading to drowning, the most common cause of death in flash floods. Injuries often occur when people are caught in collapsed buildings, swept away by floodwaters, or struck by debris. Destruction of infrastructure. Flash floods cause significant damage to infrastructure, including roads, bridges, and buildings. Fast-moving water can erode roadways and wash out bridges, cutting off access to affected areas. In urban settings, overwhelmed storm drains can lead to extensive water damage to homes and businesses. Utilities, including power lines, water supply systems, and sewage systems, are also at risk of being damaged or destroyed. Economic costs. The economic impact of flash floods is immense. Flood damage to homes, businesses, and infrastructure can run into billions of dollars, with long-term consequences for local economies. Agriculture is particularly vulnerable, as flash floods can wash away topsoil, destroy crops, and kill livestock. The cost of repairing infrastructure, providing emergency aid, and rebuilding communities places a significant burden on governments and local authorities. Environmental consequences. Flash floods can have severe environmental consequences. Rapid water flow can cause soil erosion, leading to the loss of fertile land and the degradation of natural habitats. In mountainous regions, flash floods can trigger landslides, which further damage ecosystems and infrastructure. Floodwaters can also carry pollutants, such as chemicals, oil, and sewage, into rivers and lakes, contaminating water supplies and harming aquatic life. Displacement of communities. Flash floods can force people to evacuate their homes, leading to displacement and homelessness. In some cases, entire communities may need to be relocated if the area is deemed unsafe or uninhabitable after a flood. The emotional and psychological toll of losing one's home and belongings can be significant, particularly for vulnerable populations, such as the elderly or those living in poverty. Mitigation and preparedness strategies. Early warning systems. Early warning systems are critical in reducing the death toll and damage caused by flash floods. Advances in meteorological technology allow for the real-time monitoring of weather conditions, enabling authorities to issue flood warnings when necessary. Communities that are regularly affected by flash floods should have reliable early warning systems in place, coupled with public education campaigns to ensure that residents know how to respond to warnings. Floodplain management. Floodplain management involves regulating land use in areas prone to flooding to reduce risk. This can include restricting construction in flood-prone areas, requiring floodproofing for buildings, and maintaining natural buffers such as wetlands that can absorb excess water. Zoning regulations can prevent urban sprawl into areas that are at high risk of flooding. Improved urban planning. In urban areas, better planning and design can help reduce the risk of flash floods. Creating green spaces, such as parks and gardens, allows rainwater to soak into the ground, reducing runoff. Permeable paving materials, green roofs, and rain gardens can also be used to absorb rainwater. Additionally, upgrading drainage systems to handle higher volumes of water can prevent storm drains from becoming overwhelmed during heavy rain events. Dams and levees. Dams and levees are essential components of flood control in many regions. However, these structures must be properly maintained to ensure their effectiveness. Regular inspections, repairs, and upgrades are necessary to prevent dam and levee failures that can lead to flash floods. Additionally, authorities must ensure that emergency plans are in place to evacuate people quickly if a failure occurs. Reforestation and soil conservation. Reforestation and soil conservation can help reduce the risk of flash floods, particularly in mountainous and agricultural areas. Trees and vegetation help absorb rainwater, reducing runoff and stabilizing the soil. By restoring forests and implementing sustainable land management practices, communities can reduce the likelihood of flash floods and their associated damage. Public education and awareness. Educating the public about flash floods and the appropriate safety measures is crucial. People living in flood-prone areas should be aware of the risks and know what to do in the event of a flash flood. This includes having an emergency plan, knowing evacuation routes, and understanding the dangers of driving through flooded areas. Public awareness campaigns can help reduce the number of casualties and injuries during flash floods. Emergency response and recovery. An effective emergency response is essential in mitigating the damage caused by flash floods. This includes mobilizing rescue teams, providing temporary shelters, and delivering medical aid to affected communities. Post-flood recovery efforts should focus on rebuilding infrastructure, restoring services, and supporting displaced individuals and families. Recovery programs should also address long-term needs, such as mental health support and community rebuilding. Case studies of significant flash floods. The 1976 Big Thompson Canyon flood, Colorado, USA. One of the most devastating flash floods in U.S. history occurred in Big Thompson Canyon, Colorado, in 1976. After 12 inches of rain fell in a span of just a few hours, a massive wall of water surged through the canyon, sweeping away cars, homes, and people. The flood killed 144 people and caused over $35 million in damages. The event prompted significant changes in flood management and early warning systems in the U.S. The 2010 flash floods, Ladakh, India. In August 2010, the town of Leh in the Indian Himalayas was hit by devastating flash floods triggered by a cloudburst. The intense rainfall led to mudslides and flash floods that killed over 190 people, displaced thousands, and destroyed much of the town's infrastructure. The disaster underscored the vulnerability of mountainous regions to flash floods and the need for better disaster preparedness. The 2021 Central European floods. In July 2021, several countries in Central Europe, including Germany, Belgium, and the Netherlands, experienced catastrophic flash floods following days of torrential rainfall. The floods caused widespread destruction, killing over 220 people and causing billions of dollars in damage. The event highlighted the increasing risk of flash floods in urban areas due to climate change and the need for more resilient infrastructure. Flash floods are among the most dangerous and destructive natural disasters due to their rapid onset and the difficulty of predicting them. As climate change continues to alter weather patterns, the frequency and intensity of flash floods are expected to increase. Communities worldwide must invest in early warning systems, better urban planning, and floodplain management to reduce the risks associated with flash floods. Public education and effective emergency response plans are also essential in minimizing the impact of these sudden and devastating events. By taking proactive measures, societies can protect lives, property, and the environment from the dangers of flash floods.